Alright, so this video is going to be solving quadratic equations by graphing. That means we're going to take that big long ax squared plus bx plus c equals 0, and we're going to draw a graph, and we're going to use the graph to help us find the solutions. And to kick this off, I want you to think of a key concept here. I want you to remember something to help you as we go through the process. The x-intercepts of a parabola, if you remember, the parabola makes this shape right here. The x-intercepts, where it crosses or intercepts the x-axis, boom, boom. You're always going to have two with one of these. Those are the solutions of the quadratic, that big old ax squared plus bx plus c equals 0. And those intercepts are called, you guessed it, they're called roots. I need you to remember roots are the x-intercepts, and the roots are going to be the solution of that big old long quadratic. Roots are the solution. So in my answers will say x equals -2 and x equals 3. The -2 in this case comes from the x-coordinate of the x-intercept right there, and the 3 comes from the x-coordinate of that. So let's get started. Okay, I'm kind of covering up half of this right here because I just want you to see this part here. The example, use a graph to solve a quadratic. This is what you're giving right here. In this particular case, I'm going to give you the graph, and I want you to just look at the graph and let's find out where the x-intercepts are. You know, the two boom booms where they cross the x-axis. If you look over here at the graph, you've got a parabola here, and you can see it strikes through the x-axis at 0, 0 and 2, 0. This happens to be the actual quadratic, you know, so the problem would say solve the quadratic, 2x or y equals 2x squared minus 4x. Solve that using a graph. In this case, we're really going to take the graph that's already been done for us and find out what the solution is for that. It's the best way. It's super quick. All you got to do is identify the x-intercepts, plug them in and check them, and you're done. So I'm going to back away, so you're going to pretend that this is where the work starts here. So this is what you're given, and we back away. Step 1. Okay, so we're going to use that graph to solve 2x squared minus 4x equals 0. Step 1, let's just locate the x-intercepts on the graph. Well, we locate the first one, 0, 0. We locate the second one, 2, 0. That's it. Step 2, let's just check by substituting the x-coordinates into the quadratic. Take the x-coordinates, 0 and 2, substitute them into the quadratic, and work it out. On this side, we take the x-coordinate, 0, and we plug it in for x. 2 times 0 squared minus 4 times 0 equals 0. Y'all know 0 times all this stuff is a big fat 0. Another 0. 0 is 0. Checks out. We're good to go. Over here, I'm going to take the x-coordinate again, 2. And I'm going to plug it in. 2 times 2 squared minus 4 times 2 equals 0. Remember, exponents are first. So 2 squared is 4. 2 times 4 minus 8 equals 0. We just multiplied that to get 8. And we multiply that to get 8. 8 minus 8 is 0. So we do know that we did find the correct we did find the correct answer or solutions. And our answer would be written x equals 0 and x equals 2. That one we just did, that is the nicest way to go. When they give us the graph already, wow, our work is like 80% done. But what if it's not? Okay, so here's the steps. Here's the steps to do it if all you get is the big long quadratic and you're going to use a graph to find the x-intercepts and then check your solution. Key concepts. So, how to solve a quadratic with a graph. First step, we have to remember how to write the equation in standard form. We need to write it so it looks like ax squared plus bx plus c equals 0. Sometimes this c is hanging out on this side, so you may have to do some inverse operations to get it over there. Step 2, we're going to draw the graph using a table of xy values. Remember, we did a lot of that with linear equations. And remember, in this case, from a lesson or two back, remember that you're going to start with the vertex. The vertex is the axis of symmetry on the parabolas. The middle part might be down on the bottom or it might be on the top. You know, if it opens this way, it opens this way. The vertex is the middle down there. X equals negative b over 2a. We have to start with that one. If you remember why we started with that, then that helped us. So we had a middle point, and then we had to come up with some x's on this side and some x's on this side. We could make it work out. Step 3, the last step, we're going to identify the x-intercepts and check them. After we draw our parabola, we'll find the two x-intercepts, and then we'll check. So remember, the x-intercepts will be the roots, they're called roots, which are also the two solutions. So these particular equations, this quadratic equation, usually gives us two solutions. So, example 2 here, we're going to use a graph to find the solutions of x squared minus x equals 2. Remember, step 1, first we need to write it in standard form, and we're also going to note the coefficients. We need the coefficients to help us in step 2. So, x minus x equals 2. Inverse operation on the 2. Remember, this, I need to get that on that side this time because I want to set it up. Ax squared plus bx plus c, or in this case it happens to be subtract, equals 0. So step 1. Alright, so we've got that, and we also need to designate what the coefficients are. You don't see anything out here, so that is a 1. That's 1x squared over there by himself. The b is a negative 1 as well, and c will be this negative 2. So I have my coefficients, and I can use these two to help me get the vertex for step 2. So we're gonna draw the graph. Remember, the first thing we got to do is find the vertex right here. How do we do that? The formula, x equals negative b over 2a. So I just start plugging in the coefficients down here. The coefficient of b, negative 1, 2 times a. So 2 times a is 1, plugs in right there. Come to the next spot over. The negative stayed there. I left the negative 1 there, so we can just take care of parentheses first. Negative 1 over 2, and then of course these negatives will make a positive when we divide them out. 1/2 is the answer to x, so x equals 1/2, which is my vertex, which if you remember, that's going to be the very top point. It's going to be either here when it's up, or it's going to be right there when it's down. Okay, we're still in step 2. Whew, these are a lot of work, I'll be honest with you. So I have the vertex, 1/2. Now we need to make a table of xy values. Here is my vertex. If you remember, we want to get 3 on the left side of the number line, and we want to get 3 on the other side. So I'm going to go from here, I'm going to go down. After 1/2, I can have 0, negative 1, and negative 2. And then over here, I'm going to set up 1, positive 2, positive 3. I'm going to plug the x's in for x squared minus x minus 2. Here is my quadratic that I put in standard form already. substitute in, and when I work it out, negative 2 squared, positive 4. Another positive 4. I'm sorry, positive 2. So positive 4, positive 2 is 6. Minus 2 gives us positive 4. So when x is negative 2, y is positive 4. I'm going to plug negative 1 in. When I plug it in, negative 1 squared minus a negative 1 minus 2, I get 0. That's blue because I want that should just like instantly go, when y is 0, I know that's going to be an x-intercept. It's going to be one of those guys on the horizontal line. So the good thing is we found one. We found one after on our second try. So when x is negative 1, y is 0, and I put a little star right there, that's one of the x-intercepts. So one of the roots is also negative 1. We need that. We're going to use that to check it later. I put 0 in there. When you plug 0 in for everything, all we had left over was negative 2, so that's that point there. We need to do the vertex because we need to know where the very top or the very bottom of the parabola is. So when we work this out, we actually end up with negative 2 1/4. So this is our point here for that. The next one that was really relevant in here, I want you to go ahead and do this so that I want you to do these in your notes so you have the answers there. But obviously I did this one because when I worked it out, 2 squared minus, plug in the 2 there, minus 2, I got 4, minus 2 is minus 2, and a negative 2, easy for me to say, right? Look, 4 minus 2 is 2, minus 2 more is 0. Again, yeah, we had it. We found the other root. Negative 2 is the other x-intercept, and the root is going to be 2. So here, negative 1 on the x. Over here, we got positive 2, and we found our roots, and then I threw one more point in there at 3 to find out what that is. It's nice to have 7. Wow, so we have a table now, and now we can take these points and we can make our parabola. Maybe it opens up, maybe it opens down. If we just look at our equation up here, we can tell which way it's going to open up. That's positive. So we better end up with something like this. Let's find out. Okay, over there, I got the list. I got our XY list right here. Start graphing this out. So I drew my Y and X axis, and I start graphing it out. Negative 2, 4, that's way up here. Negative 1, 0, there's one of my roots. 0, negative 2 comes down right here. And of course, my vertex, 1/2 and negative 2 1/4. So I came over a half and went down 2 1/4, just a little bit below that one. So there's the bottom point. Next one, that's positive 1, negative 2. So positive 1 down to negative 2. You can see I'm also labeling the points for you right here. And of course my other root, my other x-intercept right here. And the last one, 3, 4. So we drew the opens up parabola. Little axis of symmetry right here. I know that's the very bottom of the parabola. And now I can clearly see that I have a negative 1, x equals negative 1, and x equals 2. And I'm going to check it, my last step, just to make sure everything is okay. X equals negative 1. I take the original. I'm using the original. I'm not using the standard form. I'm taking the original, and I'm plugging in negative 1 for x. So negative 1 squared minus negative 1. That's going to be a 1. That's also going to be a positive 1, and 1 and 1 make 2. Fantastic. Next one here, x equals 2. Plug them in. 2 squared minus 2. Well, that 2 squared is 4. 4 minus 2, we all know, equals 2. Fantastic again. My answer would be x equals negative 1 and x equals 2. Look forward to seeing you in class.